and we can go in output log. So if you go here in this output log, and then if you press here r dot ray tracing, so you will see lots of commands that are related to ray tracing in this Unreal Engine, and not all of them are useful, but many of them are very useful. And if you go here in post process volume, and we see here like this max bounces, sample per pixel, and then final gather, and then brute force, and then ray tracing, max roughness, max bounces, sample per pixel, shadows, translucency, and then translucency type, max roughness. You can control all these settings from console command in level blueprint, or inside this post process volume, or from this window here, window, go to cinematic, and then movie render queue. This is an amazing tool which has been added in 4.25. I'm not sure about whether it's in 4.24, but it is in 4.25, and this makes our rendering, and this makes our cinematic rendering using ray tracing very easy and very accurate and perfect in video format. So I will be going ahead and explaining you all the techniques that is involved in using this window. But before that, let's understand how these console commands, you can add them, and then you can see their difference. So if you go ahead and then press like global illumination, and if you press global illumination here, one thing is, if you press a space and then click question mark and then enter, then you can see brief description of that command and what is the value of it being used currently in the scene. So if you like, if I went ahead and press r dot ray tracing global illumination and then question mark, this was the command, then it says help ray tracing global illumination value driven by post process volume by default if it's -1, and you can see here the current value is -1. 0 ray tracing global illumination is off. If we press 0 and click use 0, then it will be global illumination will be off, and if we press 1, then it will be enabled, and if we press -1, then it will use -1, then it will be used by the post process. The value which is given in the post process, it will use in the scene. So now as it is -1, we can see it's already given -1 here, then that means the settings which we have put in the post process volume, like global illumination, ray tracing global illumination, type, final gather, so it will pick from post processing. And this post processing volume final gather used to make the scene and then do the lighting and then give the material and optimize and then animate the camera and do every type of stops. So to do and complete all the stops in the scene, you have to keep this type on final gather, and this one has to be -1, and that way it will use this post process setting final gather which we have given here, and it will use the final gather GI, and that way it will be very smooth in our, we will get a very good frame rate in the viewport. So once we are done with our scene and we are heading towards rendering the final cinematic, I just want to explain you how we can use this and on this level blueprint. So you can see that in earlier stage, we used r dot ray tracing global illumination denoiser to 0. So it's 0, and that means the as GI denoiser is broken, and then if we click 1, keep 1, it will be bad for the cinematic rendering. So this has to be every time switched off. So we just went ahead and gave a console command on a level blueprint, so that anytime we open the scene and then press play, then that denoiser will be on, and then that GI nose denoising will be off. So let's understand this step by step. So if we go ahead and then ray tracing global illumination, it's -1, that means it's using from the final gather. But if you go ahead here again, like press up key, and then if you press 1, and then if you click here 1, that means it's now using final gather for the global illumination. And if you go ahead and make it 2, then it will use the brute force. So it will use the brute force, and you can just go ahead and give this command, like you can copy, let's duplicate this execute console command, and we will just attach it here, and then we can go ahead, copy this, right click, copy, and then paste it in here, and then space, and we can give 2 here. And now if we compile it and then simulate it, then that brute force 2 is being used, right? But it's still using that one bounce here. So to make it bounce 2 or maybe 3, we can again go here and then stop this simulation, like stop this, and we can go ahead again, copy this, and then we can attach this to here, and then we can go ahead here and then global illumination space here, and then we can see this max bounce, and we can just copy this global illumination max bounce, and if you press space and then question mark, then you can see it's -1. That means the value is being driven by post process volume, and in post process volume it's 1, okay, and 1 is for final gather. But even if we have made it, global illumination has been made to brute force by this value 2. If this value is 1, then it will final gather will be used. If this value is 2, then the brute force will be used. So we can go ahead and then paste it here, and then space, and then 3. So if we press 3, then brute force will be used because of this command. GI will be not denoised, because GI denoiser will be off because it's 0 here. And now retrace global illumination max bounce is 3 here, so that GI will be bouncing for the 3 times. So if you go ahead and then play here, so now you can see the GI is getting bounced for the 3 times on, and on brute force, even though in here post process volume it's final gather and then 1 and 1, but it will override these settings because we have put that setting specific for brute force, and then for brute force bounce to 3 in the scene. Okay, so once it's played here, then this interface will be remaining like that. That means in our scene it will be registered. So if you want to switch this off, we can go ahead and then make this to 1, so it will be now come to the final gather, and we have to just put it to 1, and then it will start, this bounce will be again 1, and then again if we compile or maybe directly play this, then this final gather will be used in the scene instead. And we can go ahead and then give commands like just duplicate it, and then find command for, like here if you go in post process volume, and then we can find the command for sample per pixel, like here. So we can go here like r dot ray tracing, and then global illumination, and then we can go ahead and then sample per pixel. So if we see this global illumination sample per pixel, then it is the sample, this setting is from here. Okay, and if you go ahead and press question mark, then it will say that it's -1 and it's taking its value from post process, that is value 4. So if you go ahead and maybe make it like 16, and now it's using, and now if you go ahead here and then press question mark again, then you can see that this global illumination sample per pixel is 16 now, and this global illumination sample per pixel removes the noise in the GI. So this noise specifically is coming from skylight, and we will be removing this noise by going into the skylight and then increasing the sample per pixel locally from skylight. But this GI in the scene, this one is responsible to remove the noise from GI, from all those spotlights and then rectangle lights. Okay, so we'll go ahead here, and then we can just copy this value again, and then paste it here, and then press space, and then we can press 16, and then we press compile, and then if we connect this and then compile and then press play, then now it's 16 in the viewport. But if we go ahead and give all these commands, that means we give a series of this console commands to control all these settings here inside this post process volume. So we can make two commands, like for one, when we are going to render the final cinematic, so we'll just connect on this, and maybe we can just duplicate this, control C, let me put it here, and then we can just control V, and now we can go ahead and then put it like here, and then we can connect this here, and we can go ahead 0 and make it 1, and then make it 1, and then we can make it like 1. And if we now, if this one is connected and compile, and then if you press play and then stop it, then now that those command will be applied. So if you want to see that whether it's now global illumination sample per pixel is 1 or not, after we connected this and then played for one time, and then that is registered in the viewport or not, you can see that by here. If you go here and then press enter, then it's now 1. So you can see here, since it's 1. So if you go ahead and make it like 16 and then compile and then play, then stop, and now if you go ahead and then see here like question mark again, then you can see 16 here because we have given 16 here. But doing this is not a good option, because every time you want to explore the scene and every time you have to be in the final gather, and you have to be just sure about when you go ahead and render the final cinematic from this window movie render queue, the commands get registered and then they are taken from the engine internally, and then applied, all the ray tracing command are applied on the cinematic, render cinematic. So instead of we going ahead and giving a two set, one for the final rendering with all the commands increased of all the commands here, you can give the console commands individually to here, because if you go ahead and then put it here, then your interface will be like jammed and you will not be able to move or do anything in the scene. So it's not wise to give this command here. And so if you have given it like this, so you have to go here and then press compile and then play and then stop and then go ahead and then see the result. And once, now you can see this face is very low. So what you can do is, instead of doing that, and then again you want to work on something and you want to do something in the viewport, then you have to go here and then just connect this to this low quality and then compile it and then play it, and then now the interface will be fast and you can do everything you want. So this is not a great and efficient way to work in the Unreal Engine or ray tracing technology or ray tracing scene. So what we will do is, we will just go ahead and then break this denoiser. As of now, this one is because absolutely important. So just click here and then play. So it was for the last time we just played this one, like we just clicked on this and then compile and then played this one. So all the values are reduced now. Okay. And now we'll go ahead, attach this and then compile and then play and then stop. So only this command and all these commands are already, which are default, almost default, are applied. And if you go here, everything is default and then applied. So how we can configure all these commands that we get here, like ray tracing and then all these commands and all these useful commands to be applied automatically whenever we render our scene. So for that, whenever we render the final cinematic of our scene, so what we can go ahead, we will go ahead to Windows, Cinematic and Movie Render Queue, and here we can just go ahead and click Render, and there is Cinematic Renders Sequence. Okay, so if you go here in Content Browser, if you see here Sequence, this is Cinematic Render Sequence, and we can add this cinematic sequence or a cinematic render sequence by clicking here and then we click cinematic render. So our this sequence which we already animated our cameras, like if I minimize it and go to sequencer and then press this button, and then if I go here and then play this, so all this sequence animation is now here ready to be rendered. After this, what we'll do is we'll go ahead in these settings and click here, and after we click here we can go ahead and click this plus setting, and then we can add a game override setting here. And in game override we will go ahead and then in texture streaming we will click disable texture streaming. So even if the in project settings, so if we go here in this project, if I click accept here and then minimize it, and then I go here in this project settings and we go here in this rendering, and if we see this texture streaming is disabled. So even if it's not disabled here, then that means if you go ahead and then use this command here, like in settings and then game overrides, which we came ahead and gave it from here, and if you go ahead and then disable texture streaming, that means the texture, no matter what there it is, that texture streaming will be forcefully disabled while we render our cinematic. So let's make this viewport to unlit as of now. And after this game override, we can go ahead in settings and then add console variables. And in this console variables, we can go here in console variables and add this button, plus button. And when you add this plus button, you can now put a console command which will be applied when we, like if you press OK and if you click render from here, then that console variables, all the console variables, we can give numbers of console variables here, which I will be showing you right now. So let's start from first of all, let's start from global illumination. So let's go ahead and then press this, or maybe you can go ahead in output here, or maybe press tilde key. You can do any of the thing, and now you can go ahead r dot ray tracing, and then tracing and then global illumination. So now we have this global illumination, and we will copy this command here from here, like Control C, and then we will paste this on here. So now it's ray tracing global illumination. If we go ahead post process volume here, now this ray tracing global illumination, it's like if we click 1, then it's brute force, like here brute force is being used if we press 1 here. If you make it like 2, then this final gather will be used. When we click this render button, then if we have given a console variable to ray tracing global illumination to 2, then it will use final gather for rendering the cinematic. And if we put it like 1 and if we render it, then this brute force will be used to render the scene. So for 1 for brute force and then 2 for final gather. Okay, so now let's go ahead and add one more console variable, and then we will search it for like this global illumination denoiser. So we can go ahead and select this, copy this one, and just go ahead and so we'll put this global illumination on 2. So Control X, Control V, and then let's make it 1, or maybe let's delete this. Okay, let's go ahead, add this from start. So we'll Control V, or maybe copy this denoiser, and then we'll go ahead and paste it here, and we'll make it 0. So if you make it 0, then our global denoiser will be off. And if you want to see whether it's on or off, you can press Control here, and now it's 0 because we have already used this on this console variables here 0, and already we have played it, so it's now showing us like it's disabled and 0. So now we have forced Unreal Engine to disable the GI denoiser because of this command given here while rendering the cinematic. So we will go ahead and click one more time here and add a more console command. And now we'll go ahead here and then r dot ray tracing and then global illumination, and now we will select this command here. So I will go ahead and show all the commands that are needed for rendering an amazing quality cinematic render from a ray trace scene in Unreal Engine. I will be just going and showing. I will just go ahead and show all those commands and how you can put and what their value should be for a preview render and for the final render. So let's go ahead and paste this, or maybe paste this and make it like 1. So now this global illumination is put to brute force when we render the cinematic, but when we work in the viewport it will be using final gather, and if we render the cinematic it will take brute force. And after that we can go ahead and right here and max bounce, and then we can select this one and then copy this command, Control C, and then add one more command here and then paste it here and make the bounce to 3. So it will use brute force here from here, and it will bounce it for 3 times. Okay, here. So brute force from here while rendering the cinematic, and the bounces will be 3 for the brute force. And now we'll go ahead and type samples per pixel. So we can just copy this command here and then add one more and then paste it here. And make it 4 for preview rendering. Okay, so for preview rendering, ray tracing global illumination sample per pixel, which you can see here, sample per pixel is 4 for default by default, and we will keep it as 4 for default because after giving all the commands necessary for amazing quality cinematic video rendering from Unreal from a ray tracing, we will render it 2 times. For the first time, we will render it on a small quality where we can get the hang about all our scene quality and the realism and the animation and the speed of the cameras and all those just general purpose knowledge. And once we are satisfied with the preview render, we'll go ahead and crank a few and then we will render it again, and I will show you how to and what values among all these value has to be increased. So let's go ahead now and then use ray tracing reflection samples. Okay, so we can see that already ray tracing reflection is already on here by default. So let's go here and then copy this and then type reflection, and then you can go ahead and then you see a ray tracing reflection samples per pixel. So just copy it and then make another console command and then paste it and also put 4 for here also. So now this sample per pixel we are using is using 4 instead of 1 in ray tracing reflection sample per pixel. By this command, ray tracing reflection sample per pixel, we will be using 4 for the test render of our cinematic video. So let's go ahead, proceed further, and we can go ahead here now, ray tracing reflection bounce or max bounce. So you can go ahead and then select this and then copy this and then make another console command and then paste it and make it value to 4. So it will be also 4. So instead of max bounce 1 at the time of our cinematic rendering, it will be 4 bounces, and 4 bounces are adequate and quite realistic. So increasing value more than 4 and 6, 4 to 6 and 8 and 12 will only increase the render time, but it will not really increase the reflection quality. But if we make it from 1 to 4, it will be useful. Okay, and we will be using max roughness to 0.6 only. So we will not be giving max roughness to like 1 or maybe 0.5. We will be using by default with default value, and default value is 0.6. And you can also see that by here, like if you want, you can go ahead here, reflection, and then type roughness, max roughness here. And if you want, you can go ahead, copy these and make a console command and then paste it here, and you can make it 1. So if you make it 1 here, then this max roughness will be 1 instead of 0.6, because 0.6 is default, and 0.6, which is default, is very good amount. So we'll not be using any value for this. So we'll not give any value to roughness. Okay, so instead we'll go ahead and give some different effect like shadows. So it's in reflection, it's using hard shadow by default. So what we can do is max reflection shadows. We can go ahead and then select this and then copy this command, and we can paste it here and make it like 2. So if we keep this value to 2, then from here area shadow will be used. Okay, and if we go ahead and keep 1, then here this shadow, hard shadows will be used. But we want our shadows of reflection to be area shadow, so we will go ahead and in reflection shadows will give it to 2. So at the time of rendering the cinematic, Unreal Engine will automatically use area shadows for rendering the cinematic. So after this, on test render, where the global illumination sample per pixel will be 4 and the ray tracing reflection sample per pixel will be 4, any graphic card will render it and the graphic card will not crash. But for final cinematic rendering, once we test our cinematic rendering on low quality, and we'll go ahead to, when we will go ahead and render it for the final quality, this quality will be bumped to 32, maybe 16, 64, accordingly, which I will show you in the future, right? So that time Unreal Engine might get crashed because of too much value in here. So to prevent Unreal Engine from crashing on the high quality values given here like 16 or 64, there is a very nice command which will prevent Unreal Engine from crashing, and that command is global illumination render tile size. So if we copy this global ray tracing global illumination render tile size, and if you go ahead and paste it here and make it 64, so even if it's 4, then it's okay, it will render our cinematic on the medium quality. But if you go ahead and bump this settings to 32, 64, then Unreal Engine will not crash because of this ray tracing global illumination render tile size, and this is very helpful. But by default it's like 0. Okay, and if we increase this quality, then Unreal Engine will be like crashing and it will not be able to render the scene if these values are high. But if you go ahead and make this value to 64, and then even if we go ahead and increase this samples global sample per pixel global illumination reflection, then Unreal Engine will prevent the movie renderer from crashing. So it's very important command you have to just keep in mind every time you want to render a high quality scene by cranking up these two values for high quality. So after that, we can go ahead one more here, add one more console command, and then we can go ahead global illumination screen percentage. So if you see here, this is screen percentage, r dot ray tracing global illumination screen percentage. So if you go ahead and paste it here, and we can make it like 100. So if you go ahead and see by default what it is, you can go ahead and press question mark here. So by default, ray tracing global illumination sample a screen percentage is 50, and 50 is not enough to get a high quality cinematic video without any noise and all those things. So this will act like super sampling in post process volume. So if you go ahead in post process volume, and if you go ahead and then go here, or maybe you can go here like MISC, and if you want to go ahead and increase it to 100 to 200. So instead of increasing it from 100 to 200 from here, we will be giving this as global illumination screen percentage to 100. So by default it was 50, and now we have gone ahead and given it to 100. So when it will render the cinematic video, it will use the global illumination quality, and this one is only dependent on the quality of the global illumination, and this one is applies on every overall every effect of the scene, and that will be too like heavy on the scene. So instead of going ahead and doing this from here, we can go ahead and then just put a screen percentage on global illumination. So it will, from default it will be 100, and the quality of global illumination will be increased. Okay, so now let's proceed to the translucency. Okay, so we have taken care of our global illumination here, and then global illumination roughness by all these commands, and on top of that the screen percent, the GI quality has been increased by this. And this, if these values are too much for final render, which will be increasing. If data too much, then this command will prevent it from crashing. So now let's go ahead and proceed to the translucency. And now what we'll do is we'll again add one more command, and then here what we'll do is r dot ray tracing and then dot translucency. So we'll go ahead and click this, check, and then we'll click copy here, and then we'll just paste it here. Global illumination, so the r dot ray tracing translucency will make it to 1. Okay, so once we make it 1, then you can see here by default global illumination. So by default you can see that translucency is not being used for a ray tracing scene. It's rasterized. That means older version of the ray translucency is used. So if you go ahead and enable this ray tracing and make it to 1, that means this will be changed to like this ray tracing. Okay, so instead of going ahead and checking this out here and then making to ray tracing, and this will slow our viewport, we can go ahead just keep it default, and we can go ahead in this console variables and give r dot ray tracing dot translucency to 1, and when we render the scene, then this ray tracing translucency will be automatically applied in our rendered scene. So now let's go ahead and proceed further, adjusting all these different settings. So now we can go ahead and press click here like the ray tracing translucency dot max roughness. So let's go ahead, select this, and then copy this, and then paste it here, and then let's make the roughness to 0.6. So it's default like here 0.6, so you can make it 1 here now. So it's in translucent roughness, if you make it 0.1, then it will be better, and in roughness, reflection roughness, we have to keep it 0.6 by default, but here we can keep it 1, so that to get a better transparency reflection, a max reflection on the translucency. So now let's go ahead again, add one more console command, and now we will go ahead and click max refraction here now, refraction raise. So we'll go ahead, copy this, and then paste it here, and now this one is like this one, refraction, the max refraction raise here, it's default 3, and we will make it 12 here now. So now 12. So when we render our cinematic video, instead of max reflection raise 3, which we can go ahead and put it here, and it will always be visible in our viewport and make our viewport heavy. So instead of this, we'll just keep it default, and we will add it on here, so that anytime we render our cinematic, it will be applied automatically. And now again we'll go ahead here, and then translucency sample per pixel. So we will just go ahead and then copy this, and then add one console variable, paste it here, and then sample per pixel to 64 here now. Or for the test render, or we can keep it 64 because this is not very taxing on the scene. It doesn't make scene it doesn't make our scene too heavy, so we can just go ahead and keep for the final quality version 1 like 64. And now we'll go ahead and just press shadows, and if we just copy these and a console variable and then just paste it here and then make it to 2. Okay, so if it's 1 here, then means this hard shadow will be used, sorry, and if it's 2 here, then its area shadow will be used. And here also we have to do the same. So ray tracing shadows we have to put it 2, so that this area shadow will be used, and in this translucency shadow we have to put it 2 again, so that instead of hard shadow, area shadow will be used. And after that we can go ahead and add one more console variable, and here like click refraction, and then we'll copy this and then we'll paste it here, and in refraction we'll keep it 0 only. So we'll not, so by default this refraction is on, and this doesn't make our glass very nice. It is I don't know how it behaves, I'm not sure about it, so I always prefer to switch this refraction off in my final cinematic. So every time I want to render a cinematic, I will just make it off. So by default it's on, so we can go ahead and then add a console variable, that ray tracing translucency refraction to 0. That means when the cinematic video will be rendered, then it will be not using refraction by default, which is it will not be using refraction, which is on by default. It will just switch it off and then render the scene. And all these settings are very much important for rendering a high quality settings, high quality cinematic video. And apart from this also there are lots of ray tracing, ray tracing. So there are lots of ray tracing console commands which you can just go ahead, select any of them, and then press a space and then press question, and then you can see what it does. 0 to disable ray tracing, and then 1 to on. So 0 off, on, and now it's 1 on. So now it's 1. That means the ray tracing is on. If you press 1, then there are lots of different commands here for ray tracing. But not all those commands are important, and explaining the effect of all those console command is not possible, and it will be like out of the scope of this tutorial. So I have just gone ahead and experiment all these console commands and studied and learned everything about all this console command, and found the best console command which are necessary for rendering a high quality cinematic video, and for the preview, and for also for the final quality. So this will be a base settings, and here it is targeted towards the preview quality build. That means good and decent quality of cinematic, but it will be rendered very fast. So we just go ahead and finished all these things. So we had a denoiser to be 0, and we made the global illumination to use 1, to use brute force by 1, and then we use ray tracing global max bounces to 3, like this one is to 3 here, and then max global illumination sample per pixel to 4 as of now. For we will be reading a preview video, so it's 4 here. And then we went ahead and global illumination sample reflection sample per pixel here to 4 instead of 1, and then bounces to 4 instead of 1 here, and then shadows to area shadow, and then shadows to area shadow. And then we went ahead and used this render style size, so that the engine will be prevented from crashing with the help of this command. And then we increase the quality of GI by this screen percentage command. And then we used ray tracing, and we enabled ray tracing because by default translucency ray tracing is raster, that means off. So we made it on by putting it 1 here, and the ray tracing max bounces is one here. Max roughness is 1 here, and then ray tracing translucency refraction is 12 instead of 3, and then sample per pixel to 64 instead of 1, and then area shadow instead of hard shadow, and then refraction is switched off. So I went ahead, and then after all finding all this, learning all these commands, most of them learning, so I learned most of the commands here, and I just found that using this commands gives us amazing result and very high quality result. So if you go here in my YouTube channel, and then you can see here YouTube, and you can see I have made these three, like let's see, like here 3D orchestras. Click on this, and then on videos. So all these three videos, if I go here and then select this, and if you have seen this video, this video has been rendered with all these commands, and this video also has been rendered, this video has also been rendered with all these commands, is only all these commands, and again this video also has been rendered with all these commands, and exactly the same procedure which I have shown from scratch to finish in this tutorial. All these three scenes have used the same technology. Ray tracing technology a bit different, which I will be showing you in maybe another tutorial. So as of now we are dealing with the full dynamic version, and all these three full dynamic versions have been used and made by the exact same technique which I have shown in this tutorial. Nothing, not even a single step has been missed or done in background. So everything in real time, and I have shown on the screen every process exactly the same. So, and you have to use this all these settings. So after giving and then configuring all the settings here, we will go ahead here in preset, and then we will go ahead and save as preset. So we'll go ahead, or before that what we can do is we can go ahead and output, and in output directory we can just click here, and then we will go in image sequences, and I will write just select this image sequence, and then I will just click here and make it use custom frame rate and make it 30 fps, and that's all you need to do here. And after this everything has been configured that it will be rendered in JPEG sequence, default rendering will be used, console variables, all these console variables will be used for preview, and once we are going to render the final cinematic, we just have to make it like 32 and this one to 32, that's all. And that will be, and if we render with 32, and if you will be rendering our scene with global illumination sample per pixel 32 and ray tracing reflection sample per pixel with 32, or maybe also you can put it 64 and try and see if your PC is able to render it. And if it's not able to render it, just go ahead and decrease it to 32 and then decrease it to 16 and see if it's rendering or not. So because if your graphic card is so weak, then even after making this render tile size 64, your scene may crash, or maybe your cinematic may crash. So if that's the case, so keep this to 164 and go ahead instead of 32 and then 64, which we will be using for our scene on my PC rendering for the final quality. But instead of doing that, you just go ahead and decrease this to 32 feet first, and then again render it. And if it's still crashing, then make this to 16 and then make this to 16 and then again render it. Even if it's crashing, then you have to just go ahead. If it has to be made less than 16, so instead of making them less than 16, you can go ahead and increase the render tile size to 128 in that scenario. So don't go below 16 here, because if you go below 16 here, then the quality of your cinematic will not be good. So we cannot go below this 16. So okay, so before, by default, we will keep it like 64, and then 30, 32, and then 64 here for the final quality build. Okay, and if your PC does not render it and it's getting crashed, so you can go ahead and decrease it to 32, and now render with the same settings. If it's still crashing, then make this to 16, and then try render it. If again it's crashing, then go ahead, make it to 16 2, then again render it, still crashing, then don't go below 16 here now. Instead, go into render tile size and increase it to 128, and see it's rendered. So if it's rendering now, then you can just go ahead and increase this first, like make it 32, and then render it with 128. If it's rendering, then again close that rendering and then come here and make it 32 also, and then render it. If it's still rendering, then go ahead and make it to 64. So you have to just customize this setting accordingly, so that you scene get renders with the best quality possible, and it's very important. So you have to just manage it. So now I will go ahead and make the default values like 64 here, and then make it 4 here, and also make it 4 here. So now this one, everything has been done for the almost preview render, because the sample per pixel is 4 and 4. So what we will do is, and you have to experiment between these two, lowering and increasing global universal sample per pixel and reflection sample per pixel, not the bounces and anything else, these two values. So I will go ahead and save this as a default preset. So we'll go ahead, save as preset, and then we will go in project and make a new folder, and we will make a folder render, and then presets. Okay, and we'll go inside this, and we will name it as render underscore reset, and just save it. So if you want, you can migrate this preset to any other project also, and if you want, you can load it, and when you close this Unreal Engine, if again open it, and you don't have to go ahead and give all these settings manually again and again. You can just go ahead, click, and then click render set. So again I will click accept, and if I just go ahead, for example, if I go ahead and remove this, and if I go ahead again and then add this cinematic render, now it will not have those. So even if it doesn't have, you can go ahead and click this render preset, and all these variables will be loaded with this disable streaming will be loaded, and output all will be loaded. And after we want, so we are going to render it the low quality version, preview quality or medium quality, or whatever you want to say. So we just go ahead in output, and here in image sequence we'll make a new folder and name it maybe 14, or you can render anywhere you want, but I am rendering in here in image sequences. And then I will just select folder, and then I will click before clicking, I will click accept, and then I will go ahead and then save all. And then before clicking render button, you have to be sure that this unlit mode is on, because if it's lit mode, then this viewport will also taking the graphic memory, and the rendering button will also be taking the graphic memory. So instead of that, you always have to use this unlit mode. Okay, and then again save this file, and then just go ahead and click render. So as you can see that our preview or medium quality cinematic rendering has been finished, and you can, if you go to this output log, and then you can see here movie pipeline linear executor base finished one job in 15 minutes 39 seconds. So in 15 minutes 39 seconds our medium quality cinematic has been rendered. So if you go here like image sequence here in G drive, and then we rendered it on in folder 14, and now we can see all these image sequences here. So now how we can see these image sequences? So what we can do is we can go on Google and type DJView viewer, and you can go ahead and then download this DJView viewer and download it here. And you can just go ahead and download for Windows exe or maybe zip, whatever you like. And once you download it, you have to install it, and once you install it, you get it here, like you see DJV viewer here. I have already installed it and put a shortcut here, and you can just go ahead and open this DJV viewer. And if you go ahead here, help, about, then you can say DJV imaging for 2.05, and you have this software which you can download for free. It's absolutely free, so you can go ahead and download it. Now you can go ahead here and then select any image and come to DJV viewer and then drop it here. And once you do that, you can now go ahead, set the FPS here to 30 fps because we have rendered it on 30 fps. And now let's go ahead and visualize and see if we have any issue, and see if we have any issue in our rendering. So let's play and see. So everything looks perfect as of now, and this camera and this camera also, everything is looking perfect. And you see we have some issue in camera 3 because it's penetrating inside the object. So we can clearly see that, and now we will go ahead and then correct that issue here. So I will minimize this window, and since we haven't given anything on this post process volume, so we still have our viewport very smooth here right now. And one more bug is that when you render your cinematic from here, then what happens is your global illumination is lost, and to regain that global illumination you will have to save the project and then close Unreal Engine and then open that project again. So once you open it, the default Final Gather GI will be on. So if you every time you render a cinematic video, that GI will be disabled from the viewport. I don't know why, maybe it's a bug or I don't know why. And after that you just have to restart Unreal Engine and open that project again, and everything will be fine after that. So let's go ahead here, select this. So you just have to be aware of that. So when you render a cinematic, the GI is switched off from the viewport. Close Unreal Engine, start it again and open the same project again, and the default GI of Final Gather will be there. So as you can see, now we have our GI again, and now we'll go ahead and select this cinematic and then cinematic render, and then again we'll click here and then go ahead and see our cinematic video where it was having some issue. So in viewport here we don't see any issue. So make the camera aperture to 0 here, and then here also camera aperture to 0. And for the safety, what we can do is we can go ahead and then just bring that camera a bit, like if you go here like this, and then we go here and we will keep attention on this Y direction, and we will just bring it like here 155, and then we'll click this button here, and then again we'll go here, and then we'll make it 155, enter, and then again we'll click this button. So now this camera is it in front, and now it will not go inside the objects anymore. And this was only the issue we had. And one more issue you can see very clearly is, let me explain you.